everyone, we're going to do subtracting mixed fractions today, section 2.9. By the way, there's only one more to go. We're getting there. Alright, just like with adding mixed fractions, there's two methods, and the methods are just like with adding mixed fractions. One is to switch everything to improper. Switch all your mixed fractions to improper fractions. Again, I would say most students prefer this method. The majority of my students use this method successfully. The other method, which I prefer and I cannot convince many kids to use, is you don't switch the mixed fractions. You just keep them improper. I'll talk about what people don't like about that in a minute. So, just like before with the addition, you might end up with some large numerators. But if you can live with that, then, there's no reason not to use this method. It can take a little bit longer and you can get some large numerators, but besides that, it'll still work. So, let's try a couple questions that we're going to use where we switch them to improper. So let's do that. Switch this to improper. 5 times 7 is 35, plus 5 more is 40, and keep the denominator the same. And then 3 times 7 is 21, plus 2 is 23, keep the denominator the same. How do you subtract? Well, you need to have the same denominator, and we do, so the denominator stays the same. And then just subtract the numerators. 40 take away 23 is 17. So there's your answer. Or if you want, make it mixed. 7 goes into 17 2 times to get up to 14, and you still need 3 more to get up to 17. Denominator stays the same. Either answer works. Alright, here's one without common denominators. So we start the same way, switch them into improper form. So 4 times 2 is 8, plus 1 is 9, 9 over 2, minus 2 times 4 is 8, plus 3 is 11, 11 over 4. Okay, we need a common denominator, so let's count by the big numbers, by 4. 4, 8, 12, 16. Now, does 2 go into 4? Yes, so that's it. The lowest common denominator is 4. So we're going to write two new fractions, well actually just one new fraction, with a denominator of 4. Only one new fraction because this one already is over 4, 11 over 4. What do you have to multiply the 2 by to get 4? You have to multiply by 2, so do the same to the top. 9 times 2 is 18. And now you can subtract. Keep the denominator the same. 18 take away 11 is 7. That works, or switch it into mixed. 4 goes into 7 one time with 3 remaining, and the denominator stays the same. Alright, we're going to do the same questions, but I'm going to do it with without switching it into mixed. Now, the reason, like when I show you this first one, I'll just show you this right now. You're going to love this. You're going to be like, yay, I'm going to do this, because look how easy this is. I subtract the fractions. 5 over 7, take away 2 over 7. Well, keep the denominator the same, and subtract the numerators. 5 take away 2 is 3. Now subtract the whole numbers, the big numbers. 5 minus 3 is 2. I'm done. Is that the number we got up here? It sure is. So, you're probably saying, oh my gosh, Mr. Wadge has convinced me. I'm always going to do this method. It's so much easier. Well, there is something that a lot of people don't like. And what they don't like is this. You might have to borrow from the first whole number. So I'm going to do an example here that will show you what I mean. We're doing the same question we did up here, right? 4.5 minus 2 3/4, but I'm not going to switch it to improper. So how do I do it? Well, I need to get common denominators, and we already figured out up here that the common denominator is 4. It's still going to be 4. So I'm going to have 4 and something over 4. That'll be my new denominator. And I'm going to have 2 and 3 over 4. We already have a 4 here, so don't need to change anything in the second fraction. But in the first fraction, you need to multiply by 2 and multiply by 2. So you get 1 times 2 is 2. Alright, now I encourage you, if you're going to use this method, to always try doing the fractions first. So let's take a look at the fractions. We have 2/4, take away 3/4. Uh-oh. Do you see what the problem is here? The problem is 2/4 is smaller than 3/4. If you subtract, you're going down into the negatives, but then you still have positives with the big numbers. What's going on here? Alright, you can't do that. It gets very complicated. So this is where you need to borrow from the first whole number. You need to borrow from the 4. So this takes a couple tries till most people get it, but you can get this if you try. What you're going to do is you're going to borrow 1 from the 4. So your 4 is now going to turn into 3. So I have 1 to give, right? I've borrowed it. So how much is 1? How much is a whole? I have this 1. I'm just going to write here, a 1 that I'm borrowing from the 4. How much is 1? Well, it's the same as 1 over 1, or it's also the same as 2 over 2, 3 over 3, 4 over 4, whoops, I should say 3 over 3, 4 over 4, 5 over 5, these are all equal to 1. If you think about it, if I have halves, 2 halves equal a whole. If I have thirds, 3 thirds equal a whole. In this case, I'm talking about quarters or fourths. If I'm talking about quarters, 1, 2, 3, 4 quarters equal a whole. So when I borrow that 1, right, the 4 goes down to 3, and I have 1 that I'm borrowing. Another way I could think of that is I have 4 quarters more. So I can add 4 quarters to my 2 quarters and end up at 6 quarters. Okay? Now, most people, when I give that example, are like, whoa, I'm never using this, it's too hard. It's actually not that hard. Here's what you do. You cross out the big number and make it one smaller, then add these two numbers, and that's your new numerator. 4 plus 2 is 6. But I just want you to be clear why we just add those together. It's because when we borrowed 1 from the 4, so I have 1 to borrow, I'm adding on 4 quarters, a whole is 4 quarters, onto my 2 quarters to make 6 quarters. Anyway, now we're home free. Subtract the fractions. 6 quarters minus 3 quarters is 3 quarters, right? Keep the denominator the same. 6 minus 3 is 3. And then the big numbers. 3 minus 2 is 1. I sure hope 1 3 quarters is the answer we got, and it is 1 3 quarters. So just like last video, I will do 4 questions, and I'll do them both methods. So over here will be the method you'll probably use, just keeping it, switching it into improper. And this is the one where we're going to keep it mixed. This is the Waj method. I prefer this. Can be faster. All right, first one, going to switch it into improper. So 7 times 4 is 28, plus 1 is 29 over 4. 5 times 4 is 20, plus 3 is 23 over 4. Oh, common denominators, love it. 4 stays the same, and 29 minus 23 is 6. Now, this is not an acceptable answer. How come? It's not because it's not mixed, it's because it's not in lowest terms. I could divide top and bottom of this by 2 and end up with 3 over 2. That's an acceptable answer. I'll take that one. Or you could switch it to mixed. 2 goes into 3 one time with 1 left over. Denominator stays the same. Either of these two is good. This one, you're only getting part marks, so please put it in lowest terms. All right, now I'm going to do the same thing again, but I'm going to do it with keeping it mixed. So try to do the fractions first of all. 1 quarter, take away 3 quarters. Uh-oh, you can't do it. 1's less than 3, so you can't do it. You got to borrow. So again, how do you borrow? I make the 7 1 less, 6, and then add these together. 4 plus 1 is 5. Okay, now I'm all set up. I can do this super fast. 5 quarters minus 3 quarters is 2 quarters, and 6 minus 5 is 1. Is that in lowest terms? No. 2 over 4, you can divide them both by 2, and you end up with 1 over 2. And that's exactly what we had here. So that's your answer. Okay, next. No more, we don't have common denominators this time. We've got to figure out the common denominators. So hey, I'll do this one where I find the common denominator first. Common denominators are 5 and 3. So count by 5. 5, 10, 15, 20, 25. Does 3 go into 5? No. Does 3 go into 10? No. Does 3 go into 15? Yes. So that's going to be your common denominator. You're going to have 4 and something over 15 minus 1 and something over 15. So what do you multiply the 5 by to get 15? Times 3. Do the same to the top. What do you multiply the 3 by? By 5. Do the same to the top. So 2 times 3 is 6, and 2 times 5 is 10. All right, so now you could switch it into improper. So my point is, it doesn't matter if you get the common denominator first or second when you're doing this method. So I could now get the common denominator. 4 times 15 is 60, plus 6 more is 66 over 15. 1 times 15 is 15, plus 10 is 25 over 15. So now we can subtract. Denominator stays the same. 66 minus 25 is 41. And you're done. That's in lowest terms. That's good. Or 15 goes into 41 2 times to get up to 30, and you still have 11 left. So that's your answer. Okay, how would you do it my method? Well, the first thing you do is exactly the same thing you did here. You'd find the common denominator, you'd switch it, you'd get your 4 and 6/15 minus 1 and 10/15. Now, can you do 6/15 minus 10/15? No, you can't. This one's smaller, you got to borrow. How do you borrow? You cross off the big one and make it smaller. Then you add the 15 and the 6. 15 and 6 is 21. Now you're good to go. Do you understand why we're adding those two? Because when I borrowed from the 4, I'm borrowing, since we're talking about 15ths, 15 15ths. That's what I'm borrowing. And if I add that to my 6 15ths, I ended up with 21 15ths, which I have right there. So you just add those two numbers every time. All right, I can do this very quickly now. 3 take away 1 is 2. And 21 15ths take away 10 15ths. Well, the denominator stays the same. 21 take away 10 is 11. And I got the same answer. All right, next one. I'll switch it to improper first. 10 times 6 is 60, plus 5 is 65 over 6. 6 times 4 is 24, plus 1 is 25 over 4. Now, you can see we're dealing with big numbers here, right? This is why I'm not so crazy about this method. We're getting some big numbers. So we got to get common denominators. Count by 6s. 6, 12, 18, 24. Does 4 go into 6? No, it doesn't. Does 4 go into 12? Yes, it does. So that's our common denominator. We need something over 12 minus something over 12. What do you multiply 6 by? 2. And what do you multiply 4 by? 3. We got lucky. It's actually not that bad. 65 times 2 is 130. But what if you're multiplying by 7 or something? It'd be really hard, right? 25 times 3 is 75. So, denominator stays the same. Okay, see, here's an example here. You got to do 130 minus 75. Ooh, not the easiest thing to do. It actually works out that it is 55. And I believe that's in lowest terms. It'll sometimes make it easier to see if it's in lowest terms if you make it mixed. How many times does 12 go into 55? 4 times. That gets you up to 48. You need 7 more. And yeah, 7's prime. There's nothing that goes into 7 except 1 and 7. So this is definitely the lowest terms. Either one of these answers is good. Okay, let's do it in my way now. So my way is to switch it to common denominators right away. So common denominator we already found was 12. We're going to have 10 and something over 12 minus 6 and something over 12. What do you multiply 6 by? 2. Do the same to the top. Multiply 4 by 3. Same to the top. So 5 times 2 is 10. And 1 times 3 is 3. Okay, look at the fractions first. Can you do 10 twelfths minus 3 twelfths? Yes, you can. This one's bigger. Oh, good. This is going to be a fast one. No borrowing. 10 twelfths minus 3 twelfths is 7 twelfths. Then do your big numbers. 10 minus 6, 4. Done. Got the same answer as this. Didn't have to deal with any big numerators or anything. Okay, last one. 8 minus 5 and 7 elevenths. Oh, okay, well this isn't a fraction. So let's make it a fraction. We'll make it 8 over 1. Minus, okay, we want it to be improper. 5 times 11 is 55, plus 7 more is 62 over 11. My goodness. What's the lowest common denominator? It's 11. So you need to multiply top and bottom of this one by 11. You're getting some big numbers again. This one, what? You're multiplying by 1. Doesn't make any difference, does it? So, 8 times 11 is 88 over 11. Sorry, I didn't put my denominators down like I usually do. And 62 times 1 is 62. So now you can get your answer. 11 on the bottom. 88 minus 62 is 26. That's fine. Or how many times does 11 go into 26? 2 gets you up to 22. And you still need 4 more to get up to 26. So 2 and 4 11s. All right, let's do this one. Hey, you know how you do this? We can do this right now. Because what you have here is 8. And how many 11ths do you have here? We have 8 and we don't have any 11ths. We have 8 and 0 11ths. And we're trying to subtract 5 and 7 11ths. Can you do that? Can you go 0 11ths, take away 7 11ths? No, you can't. 0 is smaller than 7. That's okay. Just borrow. 8 becomes a 7, and you now have 11 11ths, right? 11 plus 0 is 11 11ths. Why is it 11 11ths? Because 11 11ths is equal to 1, and 1 plus 7 is 8. Hope that makes sense. If it does, you're home free. 7 minus 5 is 2. 11 11ths, take away, what is that, 7 11ths, is 4 11ths, just like we got here. Okay, once again, people, the choice is up to you. Use one of those methods, use both of those methods. Just make sure you use a method that works. Alright, we'll talk to you for one last fractions video soon. Bye-bye.